Hello, I'm Carly McAvoy talking about area and perimeter today, but I want to talk about polygons for a second before we go into that. This is from the geometry packet. It's activity 2. You're going to watch the videos that are in this activity. I have the notes provided in your packet, and then you follow along, and then you start the problems that come along there. Polygons are plane figures. That means they're all flat in one particular plane. They have 3 sides and angles, or more, at least, I should say. We name them according to the number of sides they have. And when all the sides have the same length, we call them regular polygons. So here's pictures of regular polygons, and here's the names of those. Starting with a triangle, I did an equilateral. I did all the regular ones. So equilateral triangle, all 3 sides are the same, all 3 angles are the same. Square, we have all 4 sides the same. If they weren't, that would just be a rectangle, right? But a square is a specific type of rectangle with the same sides. And then we go on to 5-sided is penta. Those prefixes, that penta means 5. You might have played something pentagrams or whatever before where you had penta as your prefix. Hexa means 6, a 6-sided. Hepta is 7. Sometimes you'll see instead of heptagon, they'll say septagon, and apparently that's not very prevalent, but I've seen books that do. It just depends on the hepta is the Greek prefix, the septa is the Latin prefix, but they both mean 7. Octagon, that's the one people know the best because you remember octopuses have 8 legs, and then you have stop signs or whatever. And then a nonagon has 9 sides, and a decagon has 10 sides. And then we can go on from there. We have undecagon that has 11 sides, and a dodecagon has 12, and a pentadecagon has 15, and you could keep going. There's a lot of sides. A mathematician once was able to draw a 17-sided figure just using a compass and straight edge, and that was Carl Gauss, and he was so proud of it that he wanted that on his gravestone because it's really hard to draw something with 17 equal sides without using computer technology. Anyway, where do we see these kind of shapes? Well, the Liberty dollar is actually a circle, but inside that circle is inscribed an 11-sided shape. So that's actually an undecagon inside that, and it's actually round on the outer edge, but there is that undecagon that's shown inside their 11 sides. This coin is from Thailand. It has 9 sides. It's a nonagon. This one's from Great Britain, and it has 7 sides, so it's a heptagon or septagon. This is kind of nice because it's the Republic of Liberia. It's a $10 coin, and it has 10 sides. I like this. I like the idea of that. And then the 3 pence from 1952 had 12 sides, so that was a dodecagon. So they all have some number of sides, and you might ask, why don't they just make them all circles, which is what we do with our coins, even when we put something inside there. The reason we make them circles is because they vend well. When you put them in a vending machine, you can roll down something and roll out, right? Whereas if you had too many sharp edges, they wouldn't roll, or it could get caught on something. And if you do have the edges, most of the things that I've read about it is they knock down the vertex. The vertex is where 2 sides come together. They knock the vertex down so it's not too pointy, otherwise it just wears off really quickly. So this is not round, but it's getting to look round. All these kind of have a round shape. Why not square? Square doesn't roll. Square can catch edges. It's not a very convenient shape. And why did they start off round in the first place? Because certainly they made coins before they had vending machines. Because when you melt down precious metals, they kind of blob into a circular shape, and that's kind of how they started. And they go into forms more nicely that are round. And so that's why you'll see if they have a bunch of sides, it's enough sides that it's sort of circular. Okay, so that's a nice use of polygons. And then we have, of course, everyday life polygons when you drive, right? There's a few shapes you can see when you're driving, you know, octagons or stop signs. Our speed limit signs are always rectangles. Yield signs are triangles. This is red. You can't tell that's red also. These are yellow signs. This means people crossing or pedestrian crossing. And this sign here is yellow. And that means slippery road, like be careful, caution, slow down, or whatever. And so my question when I look at these is, why wouldn't we just make all road signs the same? Why aren't they all the same shape and color? Because some people can't read. So if you can't read and you see a triangular sign, you know, you can still know that that's yield, right? You can learn a lot about things in the world without reading. You know that when you see a red octagon, that means stop, right? Even if you aren't able to read that, if you're in another language or something. And so these also give us cues. The shape and the color start to give us cues. And obviously this picture would tell you a lot no matter what shape that was in. But they do try to make that so that when you see a green sign, you're expecting to be told something about turn off or here or mileage to the next city or something. So the colors and shapes have meaning as well as the design actually on the sign. So we've been looking at regular. Now remember, all the regular shapes, they have this sort of similar look. More sides, but they kind of look like that. But we don't have to have regular polygons. Take a look at 2 heptagons. If it has 7 sides, it's a heptagon. It doesn't matter if it's shaped very differently than what we saw before. It's still a heptagon. So this has 7 sides, 1, 2, 3, 4, 5, 6, 7. And this has 7 sides, 1, 2, 3, 4, 5, 6, 7. So heptagons or decagons or anything like that, it's the number of sides. It doesn't have to be regular. Obviously, these don't all have the same length. The sides aren't all the same, so that's why it's not a regular. Regular polygons have all the same side lengths. Okay, so let's look at something else about polygons. They can be concave or convex. Now, there's a really nice little website where you can go and look at those. And I think I have it. Let's see if I can get it up on my screen and look at it because I kind of liked it. Let's shrink this for a second. I think I can go here and see it. At least I hope so. The capture screen doesn't capture the whole screen, but yeah, this is nicely in the middle. So this is a concave polygon. Concave meaning that it's got this, see the angle of this is 216. If it's got an angle more than 180, then it's concave. And the more I bring that in, the more that angle goes up. Now, if I went the other way, when I get to here where it's 179, anything, if all the angles are less than 180, it's suddenly a convex polygon. Go out further, convex, convex, convex. We can move all these around, but as long as I don't get angles that are greater than 180, then I have convex. But if I get something that goes greater than 180, suddenly that's concave. Concave means you have an angle in there that's more than 180, and convex means that all your angles are less than or equal to 180. So you can have a straight angle that's concave. If I can get that out to be that, if I have it 180, which is a straight angle, then it's convex. So anything more than 180 inside angles, that gives us a concave. If I get to 180 or less, then I have convex. Okay, and this one says I can have more sides or less sides. I'll say I want more sides. You can kind of play around with it and see whatever you do. But anytime you have, and you could have more, you could have 2 that came in like that. That's doesn't matter if you have 1 or 2 or 3 that you have in there. Okay, so that's convex and concave. Let's go back to this. So I kind of go through this again, but I really I think that little on-screen thing is better than what I could have shown you. But a convex has all interior angles less than 180. And the other thing about a convex is if you draw a line through a convex polygon, it only touches it twice. Think if I was to draw a line through this one up here, right here, I'd touch it 1, 2, 3, 4 times, right? Or if I drew a line through here, again, I could touch that several times. So if you have a convex polygon, you know it's convex if you draw a line and it can only touch it twice, and it cuts it into 2 pieces. Like if I was to draw something here, I could cut that into 1 piece, 2 pieces, 3 pieces. I could have multiple pieces. So another thing is that it's going to have exactly 2 pieces after you do that. So all regular polygons are convex. So all the ones that I showed you on the last page, all of these are convex. Notice that all of them, if I drew a line, I'm only going to touch that polygon twice, no matter where I draw that line, right? So that's a nice way to remember it. And all of these, none of these have angles. One of the things that they say in here that I should have said already is that when you have something that's concave, some of the vertices, which remember are the point where those 2 things come together, some of the vertices seem to be pointing in towards the center. And so when you have that, you know it's concave. So when we look at this one up here, this right here, this vertex is pointing toward the center. So is this one, so is that one. That's how we know they're concave. All right, so that's just looking at polygons and the concavity, and we will go on to the next one in just a minute.